Hello, my name is Oliver Manuel. This is the second in a series on Nellie the Neutron. Today's story I've entitled Nuclear Science, and nuclear is kind of a synonym for what I hope will be new, clear science. The essence of today's story I've written into just a short ditty, and here it is. This is the conclusion, and I'll tell you the conclusion first because that's where we're going. That says that you and me, the elephant and the tree, the valleys, hills, and sea are all made of particles 3 that all began as Nellie, the neutron. So that's the essence of the story, and now I will go through that with you and try to explain to you how 3 basic particles constitute everything that we see in the visible universe. In the earlier video, I introduced you to Nellie the neutron. This was the picture that we had of Nellie, and this is the proton and electron. When a neutron is ejected from the core of the sun, it takes it about 10 minutes to decay into a proton and an electron. This is the hydrogen atom. We don't see neutrons pouring off from the surface of the sun, but we do see hydrogen atoms pouring off from the surface of the sun. In fact, the surface of the sun is about 91% hydrogen, but the inside of the sun is not hydrogen. The surface of the earth is about 67% water, but no one thinks the inside of the earth is almost all water. It's the same thing. The lighter elements go to the top, and hydrogen is the lightest of all elements. Now, the story I'm going to tell you about today has to do with the neutron decaying to the proton, and then the proton and the neutron and the electrons combining together to make all of the visible atoms in the universe. Albert Einstein, and if you can focus in on this one, told us almost 100 years ago now that energy and mass are 2 expressions of the same thing. So when a neutron decays to a hydrogen atom, that tells us that the neutron has more mass, or greater weight, than does the hydrogen atom. The energy that's released results in a decrease in mass. So this is what happens spontaneously after a neutron comes out of the core of the sun. Now, as I told you the last time in the earlier video, neutrons behave toward neutrons the way the north end of a magnet behaves toward the north end of a magnet. So let me illustrate this with a couple of bar magnets here on the board. In fact, the interaction's pretty strong, and these bar magnets aren't all that easy to pull apart. I've colored the north end of the magnets blue and the south end of the magnets red. So a neutron behaves toward a neutron the way the north end of a magnet behaves toward the north end of a magnet. Namely, they're repelled. It is neutron repulsion that causes neutrons to be kicked out of the sun. Once a neutron has come out of the sun and decays into a proton, then the possibility exists for the neutron to interact with the proton, and just like the north and south ends of a magnet, that's strongly attractive. So all of the atoms in the entire universe are made up of neutrons and protons and electrons, and all of those things began as the neutron, and the neutron decayed into the proton and electron, and then it's various combinations of those that make up every atom in me and you and the rest of the visible universe. Now, I told you that neutrons repel neutrons. It's like that. And protons repel protons, like that. So outside of the sun, when a neutron comes out, it decays in about 10 minutes to make the hydrogen atom. I told you that protons repel protons. They repel each other just the way neutrons repel neutrons, but they also have a positive charge on them. And so in addition to just the proton repelling the proton the same way the neutron repels the neutron, the proton repels the proton even stronger because this end has a positive charge and this end. So this interaction is much stronger. The net result is if you try to put a electron-proton pair in, compress it down into a small region of space like what's in the sun, then the proton-electron pair have more mass or more energy than does the neutron, and this reaction reverses. Okay? So, in the center of stars or in the center of galaxies, the neutron is a stable particle. Once the neutron comes out of the center of galaxies or centers of stars, then the electron-proton pair is what's stable rather than the neutron.